All right, so a linear equation, when you see a linear equation, it's going to have two variables. For now, we're going to keep it x and y. That's the most typical. The variables will appear in separate terms. We talk about terms from time to time. Terms are separated by addition and subtraction. And neither variable contains an exponent other than 1. So let me show you some examples and some non-examples. In this first example of a linear equation, the two variables, x and y, are the only two variables, and they are in separate terms. They're on separate sides of the equal sign, actually. Here's a term, here's a term, and here's a term. Terms are separated by addition and subtraction. This y is y to the first power. This x is x to the first power. If it was x squared, we would see an exponent of 2. If you don't see an exponent, the default is 1. And so when you don't see an exponent, it's to the first power. And so as long as we have two variables in separate terms, and they're neither of them contain an exponent other than 1, then it's a linear equation. This linear equation, the x and y are on the same side of the equal sign, which is okay. It's not preferable, but it's okay. This x, I don't see any exponent, so I know it's x to the first power. This y, I don't see an exponent, so I know it's y to the first power. And they're in separate terms because terms are separated by addition and subtraction. They're in separate terms. Two variables in separate terms, both to the first power. That's a linear equation. Here, the y and the x are in separate terms. They're both to the first power. That's a linear equation. Here we have two variables, x and y. They're in separate terms, but x is to the second power. That is not a linear equation. Here's what that graph looks like. It looks like it's called a parabola. It's a function. It passes the vertical line test, but it is not linear. It doesn't look like a line, does it? No. Here we have, this is interesting because we have two variables, x and y, and they're both to the first power, but they're in the same term. And if that's the case, you will not have a linear equation. You'll have a hyperbola. You get a hyperbola for that function. Still a function though. Here I see, there, right there. I've got two variables, but I've got x and y, but in this term, the x is squared, so that will be another type of parabola. A quadratic function, not linear. Linear equations are easiest to graph when they're written in slope-intercept form. And I'm not going to spend a lot of time on this today, but because we're going to do this in detail, this will be one of the last things we do. But when you see y equals mx plus b, m is the slope and b is the y-intercept. We'll talk about that soon. We're going to focus on slope first. We really need to understand slope well before we start dealing with the entirety of slope-intercept form. X and y are our variables. We're familiar with that from today's lesson. Our input and our output. And m and b are constants. They're the numbers that represent the slope. For example, you would see a linear equation like this. Y equals 2x minus 1. That means the slope, m, is the slope m is positive 2. The y-intercept, b, is negative 1. Because we don't have plus something here, right? We have minus 1. But remember, subtracting is the same as adding the opposite. And so b would be negative 1. This would just mean that the line intersects the y-axis at negative 1, and the slope is 2. I'm getting ahead of myself. We'll get to that in due time. The solutions to linear equations are written as ordered pairs, x comma y. We've just done a bunch of that. We chose an input x, we calculated an output y, and we got our ordered pair. We just did a bunch of that. That's all this is saying. You choose an input and you calculate an output. We just practiced that. Do this for at least 3 different values of x. I'm going to ask you why we do it that way on the assignment. And you make a table to organize the ordered pairs that are solutions of the equation. We just did 3 examples like that.